You might have seen the traditional Pong game before, the classic game of paddles and the bouncing ball that we all know. But what if we had our own creative touch to it and take it to the next level? In this video, I will show you how to add exciting new features to your Pong game using Pygame. Okay, so I just want to mention that this video is just for those who has intermediate knowledge of code. So if you're good with the understandings of the conditional statements and the looping structures and some basic functions, then you should be good to watch this video. And if you don't have any knowledge about Pygame, that's completely fine because every single line that I write will be explained. And with that said, if you're a complete beginner, you can still watch this video and see what you can make out of it. Also, if at some point, if you're not able to understand or follow along my explanations, or if you're not able to understand the code that I'm writing, then the best thing to do that works for me, that works for everybody, is to just imagine the code word by word. Alright, so I will start with importing Pygame first. Import Pygame. So before you do anything in Pygame, you will have to initialize it first, and to that I'm going to type pygame.init like that. So what I'm going to do now is to define a window where our game will be happening, like the animations and the visual effects, everything. So to do this, I'm going to define a variable name as window, and it will be pygame.display.set_more. Inside this, I will give the dimensions as the width and the height, which in my case will be width, comma, the height as 1000 pixels, comma 600 pixels. So you can have whatever you want. I'm just going to stick with this. So what I will do now is to define a main game loop. This is where all of our statements, functions and executions will be happening, and they will be happening constantly until we ask for it to stop. So the way I like to do this is to define a variable known as run and declare that as true, and put this inside the while loop like this. So at some point, if we want to close the loop or end the game, then we can simply make run as false. So what I will do first inside this while run loop is for I in Pygame dot event dot get, like that. So the way I like to explain the statement is anything that you do inside a Pygame window, whether it be a right click or a left click, or whether I'm pressing the S key or the B key or whatever it is, then it is considered an event. And what we're doing here is to get those events one by one and storing it in I, and so that we can check for a specific event and take action accordingly. For example, if I'm pressing the up arrow key, then the up arrow key event has occurred, and if the up arrow key event has occurred, then we have to make sure that the paddle is going up. So hopefully that makes sense. So what I will do now is first check for the quit type, which will be I.type, if I can type, which will be equal to Pygame.quit. So if the user has pressed the quit button, then we have to make sure that the game closes, and to do that, I'm simply going to make run as false. So hopefully that makes sense. Let's run our code and see. So here you see a blank Pygame window. It basically says Pygame window with the width as 1000 pixels and the height as 1000 pixels. So if I click on the quit button, then it should close. We'll see. It works. Perfect. So one more thing I would like to mention is if you want to set the caption, which we just saw as Pygame window, we can just change that to whatever we want. We will just do that by pygame.display.set caption. And inside this, we can give the title of our game, which will be Pong, but better. Just see how it goes. And you here see Pong, but better. Nice. Alright, let's get started creating the objects. And I'm going to start with the ball, which is basically a circle in 2D. And to draw any object or shape in Pygame, you will generally use the statement known as Pygame.draw the shape itself. In our case, it's going to be the circle. And inside this, you will have to mention where are you going to draw the circle, which will be the window, and the color of the circle that you're drawing, which will be blue. For my case, you can have whatever color you want. And then I will mention the coordinates, which will be ball's x coordinate, and the ball's y coordinate. And finally, you will also have to mention the radius. So we will have to define all of this. So what is going to do a specific section known as for the ball. Inside this, I will mention the radius first, which will be 15, and I will have to mention the ball's x coordinate, the y coordinate, which in my case the ball has to be in the exact center. So I'm going to do a bit of math, which will be width minus the radius And similarly for the height, which will be divided by 2, and then we can subtract the radius, so that it's going to be exactly at the dead center. We will have to mention the colors, so I'm going to have to have a specific section named colors, and inside this I'm going to define 2 colors, which will be red, which will be in RGB format, which is 255, 0, 0. And for blue color, I will have, so we should be able to see the ball now. Let's run our code and see. And you don't see anything. Well, why is this happening? And this is because we are not updating the window yet. I mean, this statement is executed, it is given to the Pygame window, but it is saying in the background it is not visually available. And this is because we are not updating the screen. And we have to constantly update the screen. And when I say constantly, it does always have to be on our main game loop. So inside the main game loop, I'm going to type a statement known as pygame.display.update. In this way, our screen is constantly updated to the latest statements that are executed, and we will be able to see the ball now. We'll see. Beautiful. And let's get going with drawing the paddles. So I'm going to do the same statement, which is pygame.draw.rectangle in this case. And we have to mention where are we going to draw this rectangle, and the color, which will be blue or red? Red? Yeah, red. And we will type in a new statement which is not done in the previous statement, which is pygame.rect, and inside this we get the coordinates and the dimensions. So which will be paddles x coordinate, comma the paddles y coordinate, comma the paddles width, and comma the paddles height. Again, we will have to define all of this, so we have to create a section for the paddles. And I'm going to start with giving the dimensions, which will be paddles width first, comma the paddles height. Since both of our paddles are going to have the same width and the height, I'm going to define this first, which will be 20 pixels, comma 120 pixels. And now we will have to mention the paddles x coordinate and the y coordinate. I'm going to start with defining the y coordinate because both of the paddles are going to be in the same coordinates in terms of height, because in y coordinate there is no difference, it's just the x coordinate. One paddle will be on the left and one paddle will be on the right. So paddles y coordinate will be, I'm going to do the same math that I did for the ball, minus the height, paddle's height divided by 2. So now the paddle is at the exact center in terms of the y coordinate, and for the x coordinate we will need 2 of them. So I'm going to have paddle small x and paddle capitalized x, which will be 100 pixels for the left hand side of the paddle, minus the paddle's width by 2. And for the height, and for the right hand side paddle, which will be the exact width, entire width of the screen, minus the 100 pixels, plus the paddle's width. Or to better understand, I'm going to give this inside a bracket and make it like you'll be able to understand this better. Paddles width by 2. So we should now be able to see the left hand side paddle because you will need to find that. So I'm going to do another statement. I'm just going to copy this line and paste it here and just change the x coordinate. Now we should be able to see both the paddles. So we will run our code and see. Nice. So we see 2 paddles and a ball on the center. Okay, let's get started with the movements. And as always, I'm just going to start with the ball, and to move the ball it's just very simple. We just have to change the x coordinate and the y coordinate continuously in the direction we want it to, and as long as we want to as well. So to do this, we can just simply add the velocity to the x coordinate, which will be velocity, and similarly for the ball's y coordinate as well, velocity y. And I will have this as 0.5 pixels, velocity x and velocity for y, which will be 0.5, 0.5. So now we should be able to see the ball moving. It is leaving trails. What? Okay, so I knew that this was going to happen because I had to encounter this problem when I first wrote the code. But then I had to record this to tell you that out of this problem, I was able to make out a whole new project which writes the letters on the screen. I have made a whole new video showcasing how was I able to do this. I will link it at the end. Now go find the solution to that problem. This can simply be just corrected with a single statement, which is window.fill, and we can fill it with black, the initial color. Now why are we doing this? Well, first let me define black color, which will be black, and it's 0 of red and 0 of green and 0 of blue. Nice. So why are we doing this statement? Well, have a look at these three statements. We are basically drawing three shapes onto the screen, and each time we're doing this, the ball is actually being drawn into a new position by just adding the velocity x and the velocity y. And since we are not filling the window, the initial drawing stays there, and we are overlapping or drawing on top of the initial drawings, and that is where we see the mistake. To the human eyes, it appears as though the ball is like leaving trails. So by filling the window with black, we are drawing the things again on a blank window, and to the human eyes, it appears as though the ball is moving and not leaving trails. So let's run our code and see as it makes a bit of sense. Yeah, ball moves and simply goes off the screen. So now we want the ball to just reflect off of the screen as it hits the end, rather than just going off of the screen. So to do this, I'm going to define an if condition. If balls, actually I'm going to put this inside a parenthesis, if balls y coordinate is less than or equal to 0, which is just basically the initial point in terms of the y coordinate of the window plus the radius, because the initial point of contact or the actual point of contact is the end of the ball rather than the radius of the center. Or if ball's y coordinate is greater than or equal to the respective height or the entire height of the window minus the radius, then we simply reverse the direction of the ball in terms of the y coordinate, which will be into equal to -1. So what this does is just reverses the direction of the y coordinate, and the ball reflects and then it goes off the screen, which is actually what we wanted to happen. We will run our code and see. That happens, ball bounces and it goes off the screen. Beautiful. Okay, so for the x-axis, we want the ball actually to go off of the screen, and if it goes off of the screen, then we want the game to basically reset, and the ball should move in the opposite direction so that player 2 can this time serve. Again, you will understand it when you look at the illustrations or the output itself. So I'm just going to directly type in the code. If balls x coordinate, again the logic is just similar to the y-axis that we did earlier. Balls x-axis, if it is greater than the width minus the radius, then we basically retrieve the ball's initial position. To retrieve it, I'm going to first copy them and paste it here, like that. And we just want the velocity's direction to be changed in terms of the x-axis. So I'm going to change it like this into equal to -1. So what this does is if the ball goes off of the screen, then basically the game resets with the ball at the center, but this time the ball is going to move in the opposite direction, so player 2 gets this this time. So I'm going to copy the statement and I'm going to paste it again because we want the logic for the right hand side paddle as well. And this time I'm going to change this to if it's lesser than or equal to 0, which is the initial position, plus the radius, then we want the initial positions retrieved and the initial data to be retrieved, and the ball this time has to move in the exact direction as it started. So hopefully that made a lot of sense, or it wouldn't have. So I'm just going to run the code and see how it is. So the ball bounces, goes off the screen, and it comes this way and it goes off the screen, and this happens again and again. If you're seeing this Pong PY, just realize that this is the original code written by me and I'm just keeping this open as a reference. You don't need to confuse anything with this. Okay, now let's get to the paddle movements. This is where the first set of initial inputs are given by the user and an action has to be taken accordingly. So if an input has to be given by the user, then we have to go to the input loop that we defined earlier. And inside this, we have to check if a key has been pressed. So to check this, I'm going to type in if i.type is equal to pygame.keyUp. Key down actually. What this does, it checks if any key has been pressed by the user, And if a key has been pressed, then we will have to check if the key pressed is equal to Pygame.key up, which is basically referring to the up arrow key. And if the up arrow key has been pressed, then we will have to define the paddle velocity, which will be equal to minus 0.7 for my case. So we will have to define this before going into the loop. So I'm going to do this here. Paddle velocity will be 0 initially, and if an input has been pressed, then this has to happen. So we can basically add this here. Paddle's y coordinate plus equal to paddle velocity, like that. So I'm going to do it for the down arrow key as well. If I dot key equal to Pygame dot key down, then paddle velocity will be just 0.7. So we will run our code and see this will make much more sense when we see the output. Okay, so we see the paddles moving, and it's not under our control, and both the paddles are moving. So there's two errors here. So the first mistake can simply be corrected by checking if no more keys are pressed. So to do that, I'm going to type in I dot type is equal to if I dot type is equal to Pygame dot key up, this refers to no more keys being pressed, and if no more keys are pressed, then we can simply make the paddle velocity to be 0 again. Beautiful. Now we should be able to control the ball. Yes, I'm able to control the ball, and both the paddles are moving simultaneously, which is the next error. And this is happening because we haven't differentiated the paddles yet. So if we differentiate the paddles, for one input, only one paddle is going to move. So to differentiate the paddles, I'm going to type another variable, which will be paddle underscore y1, which will be equal to the same thing. And this time, I'm going to change drawings. This time, only one paddle should move. If I press the up arrow key or the down arrow key, like that, very good. I'm going to define the same statements for the left paddle as well. And for the left-handed players, it's going to be, actually, I have to copy this. And for the left-handed players, it's going to be W and S. So W for up and S for down. And we will need the second velocity to come in for the second paddle. So I'm going to define another paddle velocity, which will be paddle velocity 1. And the paddle velocity 1 will change if W is pressed or S is pressed, like that. And now we can add in paddle y1's coordinates plus paddle velocity 1. Now we should be able to control both the paddles with the respective keys, like that and like that. Very nice. Also, we're supposed to make the paddle velocity 1 also 0 when no keys are pressed. So I'm going to do that, and that should give us maximum control without being continuously moved. So it moves and it stops when I'm not pressing the key, and it moves and it stops when I'm not pressing the key, like that. Very good. So before going into collisions, there's just one more thing that we will have to take care of, and the paddle shouldn't go off the screen like this or like this. We have to make sure that it has a cap and it just stays there like this. So to achieve this, what I'm going to do is to check first if the paddle is trying to go off the screen, and to do this I'm going to type if paddle's y coordinate is greater than or equal to the height minus the paddle's height, then make sure that the paddle is kept at the same position itself, like this. And I'm just going to do this for the top coordinate as well. So if paddle's y coordinate is less than or equal to 0, then keep it at 0, like this. So now the right hand side paddle shouldn't go off the screen when we try to move it down or upwards, like this. It has a cap, and it has a cap here as well. Nice. So I'm going to just copy these two lines and paste it here, and define this for the other paddle as well. 1, 1, 1, and 1, like this. Both the paddles this time shouldn't go off the screen. Just trying to move this, and very good, it's not going to go off the screen. Nice. In order to achieve this, we will need two if conditions, one for the paddle's width and one for the paddle's height, because we basically have to make sure that the paddle is within the range of the ball's width, the paddle's width. Then we will also have to make sure that the ball is within the range of the paddle's height as well. Again, don't get confused, this is going to be very clear when we see the output. So what I'm going to do now is type the if statement for the width. So if paddle's x coordinate is less than or equal to ball's x coordinate, which is less than or equal to paddle's x coordinate plus the paddle's width, then we can basically make sure that the ball is also within the range of the paddle's height. So to do this, I'm going to type for the paddle's height this time is less than or equal to ball's y coordinate, which is less than or equal to paddle's y coordinate plus the height, like that. If both the conditions are satisfied, then we can basically keep the ball in the x coordinate of the paddle itself and then reverse the direction. So to do this, I'm going to type if ball's x coordinate is equal to paddle's x coordinate, then we can actually reverse the paddle's velocity in terms of the x coordinate, like that. So what this should do, it should reflect the ball in the opposite direction and the game should go on forever, which is what is intended to do. So I'm going to run this code. Yes, it works. And for the left hand side paddle, the logic is very slightly different. So to do this, I'm going to basically type it out, I'm not going to copy paste it. So if paddle's x coordinate is less than or equal to ball's x coordinate, which is less than or equal to paddle's x coordinate plus the paddle's width, then we will have to make sure that the ball is also within the height. So if paddle's y coordinate is less than or equal to ball's y coordinate, which is less than or equal to paddle's y coordinate plus the paddle's height, like that. And I just realized that I'm doing it for the left hand side paddle, so I have to define it as y1. And what I'm going to do now is just a similar thing, but here we will have to keep it at the right hand side of the left hand side paddle. So this all makes much more sense when you look at the output or the illustrations. So what I'm going to type here is I will keep the ball at paddle's x coordinate, but not exactly at the x coordinate. Instead, we are going to keep it at the right hand side of the left hand side paddle. So I'm going to add the paddle's width, and then we can basically reverse the ball's velocity in terms of the x coordinate into equal to -1, like that. So this should reflect the ball if it hits the paddle for both the paddles, and the game is almost complete. Nice. I just realized that I haven't created any sections for the entire code that we have written inside the main game loop, so I'm going to correct it on my end and show it to you how it looks. So now our code looks much more organized, that if someone else reads this code, they basically understand what I'm trying to say, which is very important when you type out code yourself. So make sure you're doing this on your end. I've done it for my end, and I'm going to just basically go through this. These are the drawings and these are the raw movements. We're just adding the velocities to the respectives. And here we have the paddle's movement controls. We are controlling the paddle's movement. We are not allowing it to go off the screen, or we're controlling the collisions. And this is for the ball's movement controls. We just have to make sure the same things are happening to the ball, and these are the inputs. So if the user gives any inputs, then they're basically uncorrelated and they are working accordingly. So make sure that you're giving sections so that you, as well as the person who is reading your code, is very much able to understand your code. I just want to show you the prompt of how the new element that we're trying to add into the game should look like. It says active, which means that it has to be manually activated by the user, and it says once activated, the next collision of the ball onto the paddle should reflect the ball back at 3.5 times the original speed as a surprise to the opponent. This means that this is kind of a smash element, and this has to be activated manually by the user. Okay, so let's go according to the prompt itself. I will first define a specific section for this. which will be for the gadgets, and we'll create one inside the loop as well, which will be gadget movement controls, like that. So I'll go to the section that we created earlier and here, and I will define two new variables named gadget and activation. These two are considered activation variables, which triggers the gadget to be activated, and in order to trigger the gadget to be activated, we will need an input statement, and the input will be idle key, which will be equal to pygame.key_right, which indicates the right arrow key. So if the right arrow key is pressed, then we can trigger the gadget like that. So if the gadget is triggered, what is supposed to do here is, if the gadget is triggered, then I'm going to copy the statement, Control C and Control V this, and make sure that the indenting is right, like this, and just make this as 3.5. And we don't want the gadget to keep going, we want it 1 per reset, so I will make the gadget 0 back again as well, like that. So we will run our code and see how it is working. Yep, the ball is at 3.5x speed and it keeps going. Very nice. And we can do the same thing for the left hand side paddle as well. Go to the inputs and type, this time, if idle key is equal to pygame dot k_d this time, because if the D key is pressed, then you have to activate the second gadget, which will be activation, which will be 1. So if the gadget for the left hand side paddle is triggered, we're just going to do the same thing. Come here, if activation is equal to 1, and I'm going to just copy the statement. Before that, I'm going to have the right syntax, and I'm going to copy the statement, Control C, and paste it. Make sure that the indents are right, and make this 3.5, and make the activation back to 0, like that. So now both the gadgets are set. We will have to show the illustration of the round ball, which we saw in the prompt. But before that, let me just confirm that both the gadgets are absolutely working. Yes, that is working. I'm going to check for the left hand side as well. Yeah, it is working. Nice. Also, the prompt says that as a slight indication to the opponent, once the gadget is activated, there should be a small circle inside the paddle. We can achieve this by first checking if the gadget is activated. So I'm going to do that. If gadget is equal to 1, like that, then we can draw a Pygame circle inside the paddle itself. So Pygame.draw dot circle, and we're drawing this into the window, and the color will be white, and the coordinates are paddle's x coordinate plus 10 pixels, because I want to make sure that the random error is not actually happening. So paddle's y coordinate plus 10 pixels, and I'm going to keep the radius small, which will be 4 pixels, like that. So I'm going to do the same thing for the activation as well. If activation is equal to 1, then I'm going to draw a circle, pygame.draw.circle, and this will be this window again, and the color again will be white, and the coordinates will be, this time, the left hand side paddle. Left hand side paddle has paddle underscore x comma paddle underscore y1 plus 10. Have to add it here as well. Underscore, like that, and the radius will be 4. Let's define the white color and run a code and see. So white will be 255 of everything, 255 of red, 255 of green, and 255 of blue. We will run our code and see when the gadget is activated. Is the circle appearing? It does, and the gadget is working perfectly. Nice. In the next video, we will be building a counter to this gadget, which is the flash element, and also coming up with the scoreboard, and possibly cloning the ball as well.